Welcome to the webinar for RFI 190325, Free the Water. I'm Shivani Ludwig, manager of this RFI, and on this video, I'm going to describe this request for invention, the solutions we're seeking, and what's in or out of scope. If you have any questions about this topic or would like to submit a very brief summary of your idea for feedback, you can reach me at my email on the screen, sludwig@xinova.com. So this RFI is really about making healthier snacks. It's no secret that consumers are looking for snacks with less sugar and less salt, no or fewer artificial ingredients, and of course, consumers want snacks that are considered clean label. This can be a challenging trait, difficult to understand because it's a consumer-driven movement, but essentially it's about transparency and authenticity. Consumers want to know what's in their foods and know that the ingredients are familiar, natural, and simple. So, when looking at making healthy snacks, companies like PepsiCo turn to existing sources of nutrition like vegetables. Using vegetable puree to create familiar snacks like crackers or chips is a great way to introduce nutrients and flavor into a new healthy snack. But vegetable puree doesn't mix very well with dry ingredients to form a sheetable dough. And by sheetable dough, we mean a dough that can be rolled out into a smooth, flat dough that can then be cut into different shapes. As an example, sweet potato puree is 85 to 90% water, and most of this water is trapped within the vegetable cells, bound to its fiber components so that it can't be easily separated. This means that when mixed with dry ingredients to make a dough, the trapped water cannot hydrate those ingredients. So, excess water has to be added to the dough, but this tends to result in a sticky dough, often an undesirable texture too. The kind of snack which PepsiCo would want would have less than 50% water by weight before baking. This moisture content is enough to hydrate all the dry ingredients, result in a sheetable dough for easy cutting and processing. The dough would include dry ingredients like potato flakes, which have about 4% moisture, 5% oil, and 91% dry solids. The dough also includes puree, in this case sweet potato, and added water, which is currently necessary to hydrate those dry ingredients. If you're wondering what the final product for this would look like, this dough, minus the vegetable puree, is essentially the same material that's used to make baked Lay's chips. The final dough composition before baking, so after mixing, is ideally 45% moisture, 5% oil, and 50% dry solids. To achieve this composition, then, there's very little vegetable puree that can be added to the dough without having too much water or other undesirable textures. So, Xinova is looking for methods to capture that bound water from vegetable puree. We're looking for solutions that allow PepsiCo to separate out the water from those cells so that it can be used to hydrate the ingredients properly. Right now, with a puree moisture of about 88%, the inclusion rate of sweet potato puree is just 5%, which is the minimum that's desired to make the snack. But if the puree moisture alone can be used to hydrate and form dough, then the inclusion rate of the puree in the dough can be higher, leading to way healthier snacks since there's more vegetable content. We take a step back and look at the process for making this dough with or without puree. It, of course, begins with mixing. The dry ingredients are mixed with vegetable puree and water, resulting in about 38 to 45% water by weight. This vegetable puree arrives frozen, so it has to be thawed to room temperature before use. So I want to emphasize this point that PepsiCo is not in the business of making the vegetable puree. So instead, they purchase the puree and it arrives frozen. So we're not looking for methods to create vegetable puree or to puree for your fruits and vegetables in a different way. Once the dough is mixed, it moves on to forming, which involves flattening the dough into thin layers and then cutting it into various shapes and sizes, assuming that it's a sheetable dough. After this point, it moves on to baking, where first a primary oven bakes the sheeted dough, reducing the water content down to 10 to 15%. The finishing oven then further reduces the water content to 2%, suitable for shelf stability. So this baking line can push 1,500 to 3,000 pounds of finished product per hour. So any new method that's proposed should be able to accommodate that scale and speed. So digging a little deeper into the solutions that we're looking for in this RFI, we're open to a chemical, a formulation, and or a mechanical process that can be used to release the bound water from the sweet potato puree. We're also ideally looking to use that captured water from the puree to fully hydrate the snack dough, so no excess water is needed on top of the puree itself. Of course, the appearance or flavor of the vegetable puree should not be negatively impacted. And going along with that, the standard identity of the puree also shouldn't be significantly impacted. And this basically means that the method shouldn't involve, shouldn't put the nutritional value of the vegetable puree at risk. It shouldn't impact the vegetable composition. The method should easily integrate into the standard baking line, which I described on the previous slide. So if we're looking at the process and how much time your solution can take, if this solution is meant to take place during dough mixing, then it should happen in less than 5 minutes. So your solution cannot require 10 minutes in order to fully capture the water. It has to take place in under 5 minutes. If, though, it would happen during dough preparation before mixing, then you have up to 18 hours for the solution to fully separate out the water. Keep in mind, though, that if this process is happening separately from the dough mixing stage, it's important to be able to capture the water, not just separate it out. Any chemical, any formulation, anything that your solution introduces to this should be considered clean label. And you're proposing a solution that would separate out water from the cells. However, it should not prevent that same water from mixing back and hydrating the dry ingredients. In other words, the processing method should equally distribute any moisture across all of the ingredients in the dough. It shouldn't be prevented from doing that. And lastly, in order for the solution to actually be implemented, it's important to look at costs, as always. In this case, the capital expenditures should be less than $500,000 US. And we realize it's hard to estimate and know the cost of your solution sometimes. So if you have questions about this, please reach out to us. We can share a few tips on how to better understand the cost of your solution. Offhand, there's a lot you can find just by searching online. If you are able to make a quick phone call to a manufacturer and find out a little bit, maybe even get a quote, that can be extremely helpful for us. So generally, if there's any doubt about a solution being expensive, it tends to be harder to become selected. A few things are out of scope. So in this RFI, we're not looking to use fruit or vegetable pieces, fruit or veggie powder, concentrates, or concentrated juice. And there's several reasons for this. One reason includes that some of this has been done already. And the other primary reason is that using some of these leads to a product that tends to be too dense with an undesirable texture. We're also not looking for changes to the process conditions of the baking step. So the solution should implement with a line at the mixing step or beforehand, not afterwards. Any ingredient solution, formulation, etc., that is not commercially available or is not considered GRAS, which is generally recognized as safe or food grade, would be out of scope. A processing aid with a concentration of more than 1% is also out of scope. So a processing aid is defined by the U.S. Food and Drug Administration, the FDA, as an ingredient used during food processing to aid the process, but does not contribute to the final product flavor, texture, or appearance. So this processing aid can then be excluded from the label if it's used in a concentration of less than 1%. So if your processing aid has to be included at a higher concentration, at 1% or higher, then it has to be included in the label. And so for that and other reasons, it would be out of scope. As I mentioned earlier, we're not looking for new methods for purifying fruit or vegetable puree, since the puree is already purchased from the supplier in frozen form. We're not looking for methods that apply heat at or above 70 degrees Celsius. And the reason for this is that this is a level at which the nutrition, flavor, texture, etc. of the vegetable puree begins to change, break down, etc. We're not looking for reverse osmosis technology. This is a costly process. PepsiCo is well aware of this process, but they're not interested in this. Lastly, we are avoiding any solutions which may negatively impact product labeling or perception. So this is a rather broad trait, but essentially if applying or doing something to this method would result in a negative perception, it would be obvious to the consumer and result in a putting something on the label that would make, say, the average consumer cringe, then it would be an uphill battle and would not likely be implemented. So with that, I encourage you to submit your solution. The RFI closes on July 10th of this year. So that's about 40 days, that's about 2 months from the launch of this RFI. So you can see the RFI page here and view the full PDF document describing the RFI in more details. And as I mentioned on the very first slide of this presentation, you can always send an email to ask any questions about this topic or learn more about your idea. Get some feedback. We always encourage you to send a brief summary, less than 1 page, describing your idea so that we can give you some early feedback. Again, the RFI closes on July 10th, and we look forward to your solutions. Thank you.